All right, I'm going to be going over this extra review in preparation for your upcoming test. As you can see, I'm not here today, but this is just some extra review for you guys. Hopefully that you guys complete in class. I believe I did set it due by the end of class, right? But this is just an extra review. Shouldn't be super long. I'm going to go over just a little bit of everything that you might see on your test. Now, don't just rely on this particular review to prepare for your test, right? Try to look through everything, right? I had one with 25 questions that I believe a lot of you started in class last Friday, which also has great review as well, right? So there's plenty of resources for you guys. This is just an extra one that I want you guys to do in class in lieu of my absence, right? So I'll start with this first page. Reading the directions is key, right? This one just says find the sum or the difference, right? I know a lot of you during the quiz maybe overcomplicated it a little bit, right? If it just says find the sum or difference, that's all you're doing, finding the sum or difference. You don't have to go ahead and do any sort of factoring, any sort of multiplying. So let's just start with this first one. If I see a minus, right, even if I didn't read the directions, right, if I see a minus in between two polynomials, that just means I'm subtracting them. All right, and what that minus does, I know I had taught you guys to change it to a plus and then change the sign of everything. Sometimes I noticed that for some of you it gets a little bit hard to see the signs. So what I like to do is I like to distribute that negative to everything as well, right? No matter how you do it, you should get the same answer, right? And then I just rewrite the problem. So I get 3d to the fifth minus 4d squared plus 9. And then this minus is going to change all of these signs, right? So originally it was a plus, and another positive, right? But distributing this is going to give us a negative 2d squared minus 3d to the fourth, and then minus 11, right? And then from here, we just have to combine like terms. Nothing else has a 3d to the fifth, or I'm sorry, nothing else has a d to the fifth. D squared and d squared are going to combine. Negative 4 minus 2 is going to get you a negative 6. D squared. 9 minus 11 is going to get you a negative 2. And nothing combines with negative 3d to the fourth. All right, so we can just leave it like that. I know a lot of you will write it in standard form, which is perfectly fine as well, right? They're equally correct. So this, what I just wrote, is correct. Or you can write it in standard form, so decreasing exponent order. So I get 3d to the fifth. The next biggest exponent is a 4, so it's going to be minus 3d to the fourth. Then it's a 6d squared, and then a minus 2. Right, so either one of these are correct. So this is fine. This is typically what a lot of you guys do. Or you can just leave it in any order. We're not really picky on the test. All right, the next one, again, just look at what sign you have in between. I see a plus. That's not going to change the sign of anything in the parentheses, right? So the plus and the minus don't work exactly the same way. That plus is just going to keep all of your signs, right? Distributing a positive doesn't change any of your signs. I'm just going to combine like terms like normal. So 14w to the fourth plus 3w to the fourth is going to get you 17w to the fourth, right? So just combine like terms. Minus 4w to the second plus 2w to the second, negative 4 plus 2 is going to get you a negative 2w to the second, and then nothing combines with 9w. All right, so then this is our final answer. All right, this page just says to find the product, right? Product means you're multiplying. Again, even if you didn't read the directions, you can probably tell what's happening when you see a parentheses next to another set of parentheses. All right, so I'm going to take each term in my polynomial, or in my first binomial, and distribute it to my trinomial. And then take the second term and do the same thing. So when you take that 2x, it's going to be a 2x times x squared minus 3x plus 10. I can take that plus 5 and then multiply it by x squared minus 3x plus 10. All right, and then you can distribute that 2x and then multiply as normal. You're going to get a 2x to the third minus 6x squared plus 20x. All right, and then in blue, I'm going to distribute that 5. And then we're going to get a 5x squared minus 15x plus 50. And then once you have this, you can combine like terms. Right? There's nothing to combine with the 2x to the third, so it's going to stay 2x to the third. Negative 6x squared plus 5x squared is going to get you a negative x squared. 20x minus 15x is going to get you a 5x. And then nothing combines with 50, so it's just going to be a plus 50. And that's all we do for that one. All right. And now the next one, if I have something squared, right, something that I tell you guys not to do every single time. I did see it on the quiz, right? So just be careful. Don't do this for your test, right? Do not distribute that square, right? This square cannot distribute to anything in between a plus and a minus, right? So you cannot do that. All right, let me erase that. And now what you would do instead, you would write it twice and FOIL it, right? Anything to the second power means you're going to multiply it by itself twice. So it's going to be 3x plus 8 times the 3x plus 8. And then now that it's written like this, it's pretty clear that we should FOIL it. All right, so first times the first is a 9x squared. Outer times the outer, 3x times 8 is 24x. Inner times the inner, 8 times 3x is another 24x. And last times the last, 8 times 8 is going to get you 64. And then lastly, you would combine like terms. 9x squared plus 48x plus 64, right? Anything that has an x is going to combine. And then that would be the final answer. All right, now these directions, again, always read them. It says factor completely. All right, so this is where we do want to separate our polynomial into multiple factors. All right, very first thing I always tell you guys is to find the GCF. All right, so looking at something like number 5, between 18d to the 5th and 12d to the 5th, it looks like they share a common factor, right? 18 and 12 share a factor of 6. Between d to the 5th and d to the 2nd, they share 2 d's, right? So it's going to be a 6d squared as the GCF. And then whatever you get on the inside is going to be whatever you get when you divide by your GCF. 18d to the 5th divided by 6d to the 2nd is going to get you a 3d to the 3rd. All right, and then divide 12d to the 2nd by 6d to the 2nd is going to get you a positive 2, right? The d squareds cancel, and then 12 divided by 2 is 6. And then if you look inside of your parentheses, you can't really do anything more to that. All right, that doesn't really factor. That's nothing. There's nothing special about that. So this is our final answer. All right. Now, when you look at the next one, again, always check for a GCF. Sometimes it's pretty apparent that there's not a GCF. In this case, we don't have one, but we have 4 terms. All right, 4 terms you factor by grouping. I'm going to group the first 2, then group the second 2. All right, between the first 2, between 5x to the 3rd and x squared, they don't share anything in common other than an x squared. So I'm going to divide everything by x squared, and that's going to get us what's left over in the parentheses. So I get a 5x plus 1. And then it looks like between negative 10x and negative 2, I can take out a negative 2. All right, some of you will take out a positive 2, but keep in mind I want the insides of my parentheses to match. So I'm going to divide by negative 2. All right, and then doing that, we're going to get a 5x plus 1. Our 5x plus 1s do match, so then I can pull that out as a GCF. So I get a 5x plus 1 in one set of parentheses, and then in my other set of parentheses are going to be the 2 GCFs that we took out, so x squared minus 2. Nothing more I can do to this, so this is our final answer. All right, more factoring completely. Again, the very first thing that I tell you guys to look for is a GCF. Looking at this one, it looks like we do have a GCF, right? Between 2 and 32, I can take out a 2. All right, so that's going to get me 2 on the outside. And between x to the 4th and x squared, I can take out 2 x's. So divide by 2x squared. All right, so I get a 2x squared on the outside. And then after dividing by 2x squared, I'm left with an x squared minus 16. All right, so some of you will stop right here, right? But look at what's on the inside of those parentheses. Do we notice anything special about that? right? Hopefully we do. This is an x squared and a 16. These are both perfect squares. They have a minus in between them. It's going to factor as a difference of squares. The difference of squares formula is the square root of the first, square root of the second, 1 plus, 1 minus, right? Super simple formula, right? It's the same pattern every time, right? Just be careful with what goes inside, right? It looks like some of you on the quiz at least got the pattern right. You knew that it was 1 plus, 1 minus, but didn't get the correct terms. All right, just be careful. It's super simple. Just square root the first, square root the second. One gets a plus, one gets a minus. All right, that's all we have to do for that. And then if you look inside your parentheses, there's nothing more, so this is the final answer, right? Nothing more to factor. All right. Now the next one. Again, is there any GCF here? All right, doesn't look like it. So what we're gonna do when there's two terms is we had two different cases. It was either a difference of squares or it was a sum and difference of cubes, right? So before you decide that you can't do anything else to it, check all of your possibilities. It's not gonna be a difference of squares because it doesn't have a minus in between, it has a plus, all right? The only way that we can factor with a plus in between two terms is if it's a sum of cubes. So let's check if these are perfect cubes, right? So I told you guys before that there's certain perfect cubes that you should memorize. 216 is one of them, right? If I take the cube root of 216, that's gonna get me a 6. And then x to the third, right? That should be a clue, right? Maybe you didn't know that 216 was a perfect cube, but we have something to the power of 3. That should lead you into trying to check if it is a perfect cube. 216 is a perfect cube, right? 6 times 6 times 6. And then x to the third is a perfect cube, it's just x. And then the cube root of 1 is always just going to be 1. And I taught you guys to fill in the signs. It's going to be same, opposite, always plus. So 6x plus 1, that's the same, opposite, always plus. All right, and then inside of these parentheses, it's going to be the square of the first, so 36x squared, square of the last, so 1 times 1 is 1, product of the two in the middle, 6x times 1 is just 6x. And then that's all we do with a difference of cubes. All right, sum and difference of cubes. All right, nothing more to do to that. That's our final answer, right? So again, maybe the hardest part is just recognizing that you were able to do this, right? So it's the same pattern every time. I remember as I was teaching it, a lot of you were pretty comfortable and said that it was pretty simple, right? But just being able to recognize it is what makes it so simple, right? So if you remember this formula, shouldn't be too bad. All right, so we got 3 left, right? All 3 of these on this page are trinomials. They have 3 terms, all right? Now, there were a couple ways to factor with 3 terms. We either had the special case, the perfect square trinomials, either the first term was 1 or the first term was something other than 1. All right, so let's look at this first one. There's nothing in front of our x squared, all right? So all we have to do here is we're finding numbers that multiply to the last, add to the middle. So I'm looking for what times what gets me a positive 60, and a what plus what gets me a negative 17. All right, and that's going to be a negative 12 and a negative 5. If I multiply the 2, I get a positive 60. If I add the 2, I get a negative 17. So all I have to do is it's going to be x minus 12, x minus 5. All we have to do, that might be some of the simpler ones that you'll get. All right, and the order doesn't matter. If I wanted to write x minus 5 and x minus 12, that's equally correct. All right, so either way, right, one is not better than the other. They're both exactly the same. All right, let's try the same thing with the next one. This time we do have something in front of the x squared. There's a number in front, right, a 2. So I'm going to do the first times the last, so 2 times 20, and that's going to get me 40. And we're going to be doing the same thing, right? I'm looking for 2 numbers that when I multiply, I get a 40, and 2 numbers that when I add them, I get a negative 13. All right, so think about this one should get you negative 8 and negative 5. All right. 40 is a relatively small number, right? You're gonna get numbers hopefully on the test, or not hopefully. I mean, I checked all of the problems. I mean, they shouldn't be super crazy factors to check, right? So you're not gonna get like outrageously high numbers, right? So everything is gonna be completely doable on the test. So I'm gonna get an x minus 8 and an x minus 5. All right, but remember, when there's something in front of your x squared, you cannot leave it like this. I'm gonna divide both of these by 2. If it divides, you divide it, so 8 divided by 2 is gonna get you a 4. 5 divided by 2 does not simplify, so I'm gonna slide that 2 up front. It's gonna get you a 2x minus 5. All right, so that is our slide and divide method. All right. Now, the last one, it looks kind of like the one that we just did, and it might look like it has big numbers in the sense that if you did it the exact same way, if I did 25 times 49, right, I would have to do that on the side and then get a really big number here, all right? But there was another way to factor trinomials, and it's worth checking if you get an outrageously high number like this. It's worth checking if it is a perfect square trinomial, all right? So the test for a perfect square trinomial is we square root the first, square root the last, and you see if the double of that product gets you that number in the middle. All right, so 25x squared squared root of that is 5x. The square root of 49 is 7. All right, so then if it is a perfect square trinomial, it's gonna look something like that squared, right, with some sign in the middle. So let's just check if it is that, right? I'm gonna do 5x times 7, and that's 35x. When I double it, do we get the term in the middle? All right, we get 70x, that does match. It is a perfect square trinomial, so I'm just gonna bring that plus down with it. And then this is my final answer, 5x plus 7 squared. All right, so you could do it the other way, and you could find a big number and find what are factors of that add up to 70, all right? But that's gonna take a long time, all right? The only difference, the only thing that would make something like this a little bit more difficult is if you try to do it that way, all right? But keep in mind, this test is covering all of the factoring methods that we learned in this section thus far, all right? So I know on your quiz, if you saw 3 terms, it was for sure gonna be something like this. It's not for sure gonna be something like this. You just have to be mindful of that and check, and know to check that it is a perfect square trinomial. If it's not, you would do it like this, right? Either like this or like this, depending on the case. All right, that's it for your review.